What is the break-even point? That's where oh, okay. Where profit is 7. Yes.
It's the point where the total revenue supports the total.
So total profit is 1. Then from there, we started our discussion on linear program. And then we started with a graphical solution. And then we move on to using spreadsheet to resolve linear programming problems, and that's the use of computer problem. So today we'll continue with that so that we can get ourselves a bit more familiar with how to estimate that, and more importantly, to seek to understand what the results mean. For you to know how to interpret the results, even if you cannot estimate the equation, you should be able to please. You are making noise. Why I will the same. You understand? The link I shared is on the first, it is the same link we have been using. So I don't see why somebody should be waiting for a link when a new link will not create. Okay. Now, as you can share it on or ask the chat to share. Now, so you have to understand how to interpret the results, because in certain situations, I will just do the estimation myself and present the results to you and ask you to interpret the results. Okay. So in that case, you don't need to do a net calculation. The food has been cooked for you. Your only problem is what? Eating. Okay. Your problem is what? Eating the food. And you will come because, and you would see from what we did the last time, you can have a heavy amount of output generated from the computer. The question is, what sense do you need out of the output? And we'll do quite a lot of that today. Now, but I would also assume that by now you all have the software installed. Is that a fair assumption? Well, it's going to be assumption. Yes. I can proceed on cities I who are not installed and has computer here. Yes. That's around you. Why the problem? You know, it cannot be why. Open. Hey, why? Then the same problem. Wow. Then we have to deal with that separately. Okay. So it means that I can proceed on that assumption, even though I know that two people have not been able to successfully install it. Now, but you have activated the solver. So no. remember, okay, so let me explain. Remember that I showed you two ways of solving them. Right. Using the what? Excel QM. Excel solver. At least if you don't have the QM, you should have the solver. After the solver is inbuilt in Excel. You don't need to download any software. Okay, so confirm that. Because you can solve the problem either using the Excel solver or using what? Excel, which I asked you to install. So at least you should be able to activate that as an add-in. Okay. So once that is done, you should be able to hello. Why? Why are you disrupting my class? So remember last year, I wanted to say last week. Last year, we resolved this, and I gave you this sheet. So you have it. I posted this on the platform. Exhibit 3.1. Okay. So this is what we used. And this is the solver I talked to you about. So data. You will see the question mark followed by solver. At the extreme, if you are facing the screen, that will be all right. But at the extreme left of the screen itself. So once you open exhibit 3.1, and then you go to data, and then you click on solve. That's the solver. It's going to answer or is going to calculate the answers for you and fill the optimal values here. These empty spaces will be filled. Now, if you have already you already solved the problem and save the Excel sheets, when you open it, these zeros will not be there because you have already solved it. And this will not also be empty. This will not also be empty. This will not also be empty. Okay. So if you want to resolve it, you just need to delete the values for bows and marks. Those are the changing values. Okay. I don't delete this one because this is a formula. If you delete this one, you have messed the sheet up. So you don't delete it, you can't delete this. This zero, this is a formula. Remember, this is also a formula. This is also a formula. This is also a formula. So for the formulas, once you delete in a formula on a formula cell, then you have what? Deleted the formula. So unless you write the formula again. So take note of that. Okay. So once you open exhibit 3.1, you go to data and then go to data, click on this and to give you the answer. Okay. Or the solution. Now, if we solve the problem in this manner, so I showed you this procedure, and then once you do that, this will be the solution. So we found that the number of boats to manufacture is what, 24, and then that for max is 8. Yes. Then you will see that when you come to under resources, where we have zeros, and I said it's formula, that's the left-hand side, where we have usage, is now populated with values. The values that are under usage are the total values of what? The respective constraints or resources that have been used in arriving at the optimal solution. Okay. So you see that here we have what? 120. And if you look at the question, we said that the total number of labor hours available was what? 40. And the total amount of clay available or quantity of clay available was what? 120 pounds. So the solution tells us that we have no leftover. Remember that the leftover, I said, is called what? The slack variables. And we said that the slack variable is what? The quantity you need to add to what? The left-hand side, so that the constraint will become what? An equality constraint. The inequality constraint will become what? An equality constraint. So that the leftover cell is simply the difference between this and that, usage and available. This was what was available. And when we do the calculation, we've seen that the optimal solution slack is 0. No leftover. Yeah. Now, if we, and I will come to that. If you are on your computer, let's generate this report. Yeah. Let's generate the report that is 3.1. 3.1, which we are open the Excel sheet. The Excel sheet I shared with you last year. Called Exhibit 3.1. That's what we open. Open that. We have to generate this report. So I will tell you what the report means. You don't have to get the platform, download it, and save it. It's an Excel sheet. Not Excel sheet I shared. Yeah. So when you open it, it will be like this. Okay, so this what I said, you should open Exhibit 3.1. Okay. So that we can proceed. What's that? Are you there?
The file on the same page.
Okay, but are you there yourself? Open it, so that we can move together. So, what's that? Are you there?
Yes.
All right. So once you are there, let's solve it. So go to data. Once you are on this page, go to data. And then click on solver. Just click on it once.
The active cell, where should the active cell be?
Or you have not yet. Now, if you click on solver, click on solver, the window that comes. So once you are there, click on solve. Click on solve. Some of you are there, there's some noise. All right, so let's continue. So I said that once you click on the solver and the window appears, you click on solve. Okay, it will take you to a new window where you can generate this report, and I'll show you how to do that. You will see that you have something like this. You have answer, sensitivity, and limits. Okay. On answer, just highlight answer. Answer. You see answer. Just put the cursor there and select it. You can select both the answer and then the sensitivity. Yeah. So you are selecting it. Select answer, select sensitivity. So once you do that, then you can get to okay. So when you click OK, you will see that 2 new sheets will be added. So we already have the answer reports and then the sensitivity test. So we are solving it again. So it creates answer 2, answer report 2, and then sensitivity report 2. So we are just duplicating what we solved already. Okay. So my interest now is to take you through the answers or the results. So let's look at the answer report. Any of them is the same. So the answer report. First, we have cell. That's the cell number where we had our objective function. Okay, then that's where you have the optimal profit being inserted. So the values there, so it have what the name is profit. Kindly pay attention. Okay, we have profit, and then the original value is what 1,360. Final value 1,360. So that's the optimal solution. Now that's the maximum profit. That's so it means that the maximum profit is 1,360. Okay. So you can interpret this. Once I give you output like this, be able to interpret it. Then we have adjustable cells. This is a second output. This is a profit, the maximum profit.
So the first one represents the maximum.
Yes, the profit. That's the maximized, the optimized value. Remember that the problem was for us to have click. If click to what? Maximize profit. And so the maximum profit that Click can get is $1,360. And it will produce, and that's where the adjustable cells come in. Remember that we were looking for what? The values of X1, X2, which represented what? Bulls and what? Mass that should be produced in order to get this maximum what? Profit. So if we must get the maximum profit of what? 1,360, then we have to use what? We have to produce 24 bulls and then what? 8 mass. So it is the production of 24 bulls and 8 max that will give us what? The maximum what? Profit. Now, we now come to the constraint cell. Within the constraint cells, remember that these were the right-hand side values. 40 labor hours, 120 pounds. So that one is a repetition of what happened. But what is interesting here is the solution is telling us whether the constraint is binding or what? Non-binding. Whether the constraint is binding or non-binding. If a constraint is binding, what it means is that if you change the values of that constraint beyond some level, you can no longer achieve the maximum profit. Then we say that the constraint is binding. And you see here that it has given us the status binding, which means that beyond some boundaries, and the boundaries can be either below, and we'll establish those boundaries later on. Beyond some boundaries, then the $1,360 of profit is no longer attainable. So we feel like that constraint is what? Binding. It's a binding constraint. Okay. So that is the report for the answer. And that is how you interpret it. Okay. Now, if we, of course, we resolve the problem also using the Excel QM. So we've done that before. I will not. But if you open the Excel QM, you can enter this data. Remember, okay, maybe let's, if you have installed it, we can just go through it very fast. It will not take us time. Okay, so you can open the Excel QM. I'll come back to the sensitivity report and interpret it. Okay. But I want those who were not here to also go through the usage of the Excel QM to solve the same problem. So for the Excel QM, once you have it installed, you click, double click to open it. This is a window that will come. And once you have this window, sorry, you have this window, this will not be there. So under the models listed here, you see linear programming. To the extreme left, you will see linear programming. You click on it. Once you click on it, this window will now appear. Once this window appears, all you need to do is to, under title, you can type Beaver Creek Poultry Company, or you can type anything there. It will not change the answer. It's just to let you know that that is what the company you are solving the problem for. Then you see number of constraints. You change it. If you click on this, the upper part, it will increase the constraint. If you click on the lower part, it will decrease it. So the constraint should be 2, because we have our labor and what clay constraints. Then if you come to the number of variables, there are 2. We are producing caps and what max. So once you set this up, just click OK. If you click OK, you have maximize. You have constraint 1 here, it will be constraint 1. Yes. Constraint 2. So you can type these things there. You can type this, you can type labor in bracket hours, you can type clay in pounds. It's editable, so you can change it. Then you can enter these values. These values have to be entered in their respective positions. So once you enter the values, you see the green arrow with solve. Just click on it, and it will solve it for you.
Prof, there's a question in the chat.
Yes.
That one says, please, sir, can you take the indication on the constraint side too? Considering the constraint is binding. Hello, Prof. Hello, Prof. Hello, Prof.
So once you click on it, you have several results. But for the XLQM, the graph will be there, which we showed. If you look down, if you have done it, if you look down there, the reports are there. So at the top there, you see solution list. If you want to pick on any of the solution values, over here, you see solution list. If you click on it, all the solutions that have been provided will be shown. So you can click on them. If you want the graph, you can click on it. If you want the ranging, you have constraints, whatever, they are all there. So it gives us the same solution. But there's another illustration here. You see on the last column, we have dual. We have what we call dual. The dual values are also called marginal values. Marginal values. Now, in some situations, we call them shadow prices. Shadow prices. So, for instance, if you take labor, the marginal value is 16. If you take clay, the marginal value is 6. The marginal value of 16 for labor simply means that when we employ an additional labor, profit will increase by $16. Okay? So that's why we call it the marginal value. The marginal value or the shadow price tells us the impact that a unit addition of the resource will have on the objective function. So here, if we add an additional labor, it will increase profit by $16. If you come to clay, the marginal value or the dual value is 6, which means that when we add 1 pound of clay, it is going to increase profit by what? $6. Another way to explain the marginal value or the shadow price is to say that that is the maximum amount one will be willing to pay for an additional unit of the resource. Because this is the value that the resource is bringing to you. So you will not pay more than that for an additional unit. But that doesn't mean that that's how much you should go, for instance, buy 1 additional pound of clay. Take note of that. Okay. We are saying that as a manager, this guy should to know that never buy an additional pound of clay more than what? $6. Because it is going to add $6 to what? Your profit. So don't pay it more than the value it will bring. So in economics, we usually calculate for the marginal value. The marginal value, an addition to what? Profit as a result of what? An addition of 1 unit of what? The input or resource. Okay, so that's what we call the marginal value. So take note of that. So that this is a framework that gives the manager an idea. So if you find that somewhere they are selling labor at 3 additional labor at $3, it means that when you hire such a labor, you are going to get 2 times the value that labor is, the cost that the labor is going to use. So if you know these values, you will not go and then hire labor more than $16. You would negotiate to hire labor at maybe 10, or if you can even, that's why some people if you can even pay them $2 and make extra 15 or 16 from there, extra 14 from there, you'll be fine. Okay. So that is it about the marginal value. If you were to look at the graph provides the corner solutions as well. The point, that is the origin, that is what is at the top there, where the Z is 0. X1 is 0, X2 is 0. So profit is 0. So we don't consider it because it means no production is done. Okay? So no profit. Then some of the other points are going to give you 1,000 and then 1,200. But the one that gives you the highest is what? 1,360. And that is this optimal point. Okay? So you settle on that. So we have, you see that it has colored the answers, the graphs. The violet line is the actual profit line. And in economics, when we say actual profit line, we mean that every point of the line, the profit is the same. So actual means equal. So it means line of equal profit. In other words, once you are on that line, the profit is what? The same. Okay. Meaning that if I am at this point, the profit is the same as when I'm at that point, or that point, or that point. So we call it the ISO what? Profit line. Then these are the constraint lines. Okay. The constraint line. Now, for a manager, even though the linear example, the linear programming example we are using, we seem to suggest that the manager is certain of the value of the parameters. So, by the parameter, we're talking about the coefficients that are attached to x1 and x2, and even the x1 and x2, that we are sure of them. But that really is not the case in practice. So we need to determine how our optimal solution will be impacted when there are changes in the value of the parameters in the model. So if we get back to the model, where we have, so I'm talking of these parameters, 40, 50, 1, 2, 4, 3, 40, 120. If any of these parameters will change, how will that affect the optimal profit? And that is what sensitivity analysis is about. So for instance, instead of labor hours available being 40, if we make it 50, how will that affect the profit? And then also, instead of clay being 120, if we make it 180, what will happen to the profit? The same thing, instead of this being 1, if it is 3, what will happen? Instead of this being 4, if it is, say, 5, what would happen? And that is what sensitivity analysis is all about. You want to know the effect of changes in the coefficients of the parameters on the optimal solution. Okay. And that's why I made you to generate the sensitivity report. Remember, we discussed the answer report, so we have to go and then discuss the sensitivity report. So if you go to your Excel solution, one of the sheets, you have the sensitivity report. So sensitivity report 1, okay? You will see something like this, what we have on the board. Amongst this. So here too, we have to be able to understand what the output is all about. First, we want to examine the sensitivity. The upper part is the sensitivity report for the objective function. The lower part is the sensitivity report for the constraints. So take note of that. This is for the objective function. And these are the coefficients of what? The objective function. If you remember, it was z is equal to what? 40x1 plus what? 50x2. Okay. So this is a 40, this is a 50. Okay. So these are part of the question. And the final value, that is the solution. We'll discuss that. Okay. These are the optimal levels of goals and mass that we should produce in order to attain the maximum profit of 1,630. Now, remember that we said that if this firm must maximize profit, it has to produce what? 24 bulls and then what? 8 max. Now we want to know within that what range of the values of the coefficients of the objective function, which are 40 and 50. Remember, in the objective function, we had what? X1 40 or 40 X1, what? 50 what? X2. So these are the coefficients. So we want to know what the range of these coefficient values. Will we still need to maintain 24 versus 8 to be optimal? And that is what we call the optimal solution range. So we have the sensitivity range. Okay. Now, with the sensitivity range, we have two values. Okay, so it's a range, which means that it falls within what? Some interval. Okay. So we want to know within what interval will our optimal solution still be 24 bulls, what? 8 what? Max. Within what interval must this coefficient fall for our optimal solution to still be 24 max? For 24 bulls for 8 what? Max. To let you understand that the Excel solution has provided 2 extra columns. Allowable increase and then what? Allowable decrease. Allowable increase and then allowable decrease. Let me take the allowable increase. The allowable increase value for both is what? 26.67. What does it mean? It means that Beaver Creek can increase the coefficient of the objective function for both, which is 40. By 26.67 and still remain in the optimal solution. If an increase is above 26.67, then 24 bulls will no longer be the right amount or number of bulls that should be produced. Take note of that. I'll take it again. Yeah. The allowable increase You are the one getting. The allowable increase means that this objective, the function of the objective coefficient can increase up to what? By 26.67. And the solution will still be what? Optimal. In other words, we can add 26.67 to 40. And then the right number of holes to produce will still be what? 24 in order to maximize profits. That's what it is. So if you add 26.67 to 40, which will give you what? 66.67. That is for the upper limit. The upper limit or upper bound of the sensitivity. So that's the upper bound. Now, the allowable decrease is a reverse. What that means is that we can have this coefficient decreasing by what? $15. Remember, this is in dollars. And still, the optimal value will be to what? To use what? 24 goods. In other words, if this coefficient decreases more than 15, so for instance, 16, it will mean that Beaver Creek can no longer hope to produce what? 24 bulls and hope to still maximize what? Profit. Which is what? 1,630. The profit will change. It is no longer within this solution. So that if we subtract this 15 from the 40, what do we get? 25. 25. That is the lower part. We call it the lower bound, or the lower limit. Or bound, the lower limit or bound. Now, so the sensitivity range for is usually denoted for any value xi is given by ci. In other words, if we are dealing with x1, the sensitivity range value is what? 0. So what that means is that we are saying that the sensitivity range for volts, which is x1, x1 is given by 25, which is the lower bound. Okay. Less than or equal to the C1, less than or equal to what? 66.67. Okay. So this is the sensitivity what? Range for x1. What it means is that Beaver Creek can have the profit per bull. Remember, the 40 here is the profit for per bull. Okay? He can have profit per bowl moving within this range. And then still produce 24 what? Bowls as the optimal solution. If any value lies outside this range, in other words, if profit per bowl falls outside this range, then the right number of bowls we produce is no longer 20. That's what I'm saying. If profit per bowl falls outside the sensitivity range, then 24 bowls is no longer the optimal one solution. We have to resolve the problem. In other words, you can take the report from the computer and then you don't need to redo the analysis again to be able to establish what? The sensitivity analysis. Because one way of the analysis, the obvious thing, for instance, let me show you something before I come to the upper bound. So for instance here, if for instance, we now say that profit per unit changes to 100, you just come to this cell and change this to 100, not so. Change this to 100 and solve it and compare the answer to what you solved originally. That's the easiest way to what? Go about it. Okay? So if, for instance, the profit per mark also changes to 80, what it means is you just need to replace this 50 by what? 80 and resolve the problem. And you will see the effect on your answer. And the implication of this analysis is that when you change this 40, if you change it to 25, the answer will still be 20. Okay? The answer here will still be 24. If you change it to 66.67, the answer will still be what? 24. But as soon as you change it to 17, the answer will change. As soon as you change it to 20, the answer will what? Change. And that's what the sensitivity report is all about. And you need to understand how to deal with them. All right, so let's look at the, I told you that the upper part is the sensitive. Oh, or maybe let me go. Now, what I have done for X1, we can do the same thing for what? X2. So if you want to get the sensitivity range for X2, it will be what? 50 plus what? 30. And that will give you what? The upper limit. And then you now come to what? The lower limit. 50 minus what? So you see that for that one, you have what? 80 what? 30. 80 what? 30. So that one will be C2. So X2, the sensitivity range for X2 will be what? 30 less than or equal to C2, less than or equal to what? Now, if we were to, if you check on the Excel QM solution, that one doesn't give allowable increase or decrease, but it gives you the upper bound and the lower bound. So if you have that solution, go back to the Excel QM solution. No, yes. Now, if you go to the solution of the same problem using Excel QM, if you click on the solution report, if you click on the solution, one of the report is ranging. Click on that one. It will show you both. It will not show you allowable increase or decrease, but it will show you upper bound and what? Lower bound. Let me see whether I have it here. Yes, it's here. So that one will show you lower bound, upper bound. So that one, it gives you the what? The sensitivity limits straight away. So you don't need to add or subtract. Okay. But I can give you a lot of them. Okay. Yes. Now, so if you were to use
this one,
if you will look at this, okay? Hello, let's be together. This is the sensitivity analysis report for QM for Windows. Okay, Excel QM for Windows. That one, it gives you the lower bound and the upper bound straight away. So that if we take this, the lower bound is 25. The upper bound is what? 66.667, as we found here. What this means is that profit per board can decrease up to $25 per board. And the coefficients, that's the optimal solutions, solution will still be 24 watt volts. But if it decreases beyond $25 per volt, then the optimal value will no longer be what? 24 volts. That's what it means. Then you count here 66, the upper bound 66.67. Meaning that profit per volt can increase up to what? 66.67. And will still be within what? The optimal solution. If profit per volt increases beyond that, then it means that 24 volts will no longer be what? Optimal. So we have to solve the problem again, decide the best what? Number of what? Volts to produce. It will no longer be what? 24. In other words, so long as profit per volt is within this range, maximum profit. That's what we are saying. It will give you profit, all right, but that is not the maximum profit. You now have to find what? A new solution to tell you how many bulls what to produce, given that profit has increased beyond what? The sensitivity range. Okay? So that's really what the story is all about. Now, if you come to the sensitivity range for the constraint variable, remember that I already told you that, yes.
So, sir, in this case, when you interpret the X1, you have to do the same to the X2.
Why not? If that is
Because always you do interpret the X1, then you forget the X2.
I don't
That's
forget.
That's right. Okay, because
it's the same.
That's
It's by extension. Okay, it's by extension. The essence is the same, so I don't need to repeat myself.
Okay. Because for example's sake.
For example, you may not just have X1, X2. You can have up to X8. So what is important is for you to know how to interpret one. The essence is the same.
The rest is bonus.
Now let's get to this.
So please, in our interpretation, in my interpretation, when I say if the lower bound, if it decrease less than 25, if I say less than 25, would I be?
You are not interpreting the lower bound. Okay, you are interpreting the value of the objective, the coefficient of the objective function. Okay, you are saying that if this one decreases from 40 to what? 25, the right number of bulls to produce is what? 24. If it reduces beyond 25, then 24 bulls will no longer be the right number of bulls to produce in order to be optimal. I don't understand why this should be qualified.
Mathematics.
No. Now, let's look at the coefficient for the lower for the constraint function. We have labor. And remember that I told you about what? The dual value. I said that dual value is also called
The shadow price.
the what?
Shadow.
The shadow price or what? The marginal value. Okay. So you interpret this as what? Shadow price or marginal value. So 16, I said that what? When you have what? An additional unit of what? The right-hand side variable or the right-hand variable. Remember when we were doing the equation, the number that was at the other side of what? The equation, we call it the right-hand side value, which are these ones. Okay. When the right-hand side variable, which is what? For instance, the labor constraint increases by 1 unit, profit will increase by what? $16. If the right-hand side complaint, which is what? The bound increases by 1 unit, then profit will increase by what? $6. $6. So take it. So that one also has what? Lower bound and upper bound. So that the lower bound and the upper bound for the constraint, they show the range of values for which the shadow prices are valid. The range of values for which what? The shadow prices for the constraints are what? Valid. In other words, if labor decreases beyond 30, the shadow price of 16 will no longer be correct. You have to re-estimate. But so long as it decreases but not below 30, then the cost of an additional unit of labor will remain what? 16. Then you look at the upper bound, telling us that so long as we increase the right-hand variable, which is the total amount of labor available, up to 80, the shadow price will remain 60. If it moves beyond 80, then the shadow price of 16 will no longer be valid. By extension, for clay, if the total quantity of clay available decreases up to 60, then still the marginal value will be what? 6. But if it increases beyond 160, then the marginal value will no longer be what? 6. But so long as the increase is between 6, or the change is between 60 and 160, then the shadow price will remain what? 6. Okay. So once you are given this out, and I tell you to write the expression for the lower and upper bound, you should be able to write this expression out. Okay? Given these results, you should be able to write it out. Okay? Then I'll tell you, okay, so what does that mean? In plain English, what does that mean? Boss Rep, I still have to steal some time for your information. Okay. So the sensitivity analysis can still involve changing individual constraint parameters, adding new constraints. In other words, you can have more than 2 constraints. You can include adding new variables. So you can add a 3rd variable. And then the answer would what? Still be this. I mean, you can still do the analysis. So when you go, you can follow and then do the analysis. But I want us to take this example. Yeah. I share with you the Excel sheet. I share with you. Because once we set up like this, we don't take advantage and do it. Next time we come and we announce booting our computers. That one alone wastes a lot of time. So once I have you here, I have to make good use of you. I love you.
Bro,
is talking in parallel.
No, I'm speaking in plain language.
Making good use of you so that you learn better. Okay, go on.
Now, if you look at the other slide I shared with you yesterday, that one is just devoted to examples of linear programming problems. So if you get the fourth and actually this one is not on the outline. Because I do that once we go through this in class, that is what we have just done. If you pick that chapter, you will be able to solve all the questions. Okay. So they extend and show us how linear programming problems can be solved. So that slide, you have to go through it and be able to practically, with your computer, solve the problems. Next time we are going to change a different topic. All right, so let's solve this problem. So this is the problem. We have a 4-product t-shirt, sweatshirts manufacturing company. So there are 4 different products. And the problem is that, so this is a constraint. Production must be completed within 72 hours. The truck that is going to load the t-shirts for distribution, the maximum capacity is 1,200 standard size boxes. So it's a constraint. Okay. Then standard size box was 12 t-shirts. The constraint. 1 dozen sweatshirts box is 3 times size of standard box. It's a constraint. Many dozens or dozens of gearboxes of each type of shirt should be produced. What is to understand the problem? Because if you don't understand the problem, you cannot set up, you cannot construct a model. So for me, I see the problem more, the quality should be. That one is not any help. But how to, for instance, given this problem, to construct a model, tell us the objective function, tell us the constraint function, and then set up what the model, and then you test it. So that is really where the catch is. Okay. So let's go through them. So this is a detailed analysis or presentation of the problem. So we have t-shirts, and the t-shirts are 2 types. We have one where the embossment is only on the front. See the embossment. Then we have another, the embossment is on front and back. Okay. And they have different prices. Okay. So 1, 2. So t-shirts are 2 categories. The same with the sweatshirts. Front and what? Front and back with different amounts. So this is what we want to produce and put them in boxes. And we are told that this one will be standard box, the t-shirt, standard box. But if we put the sweatshirts in boxes, the boxes are 3 times what we have for the t-shirts. So you have to take note of that. Okay. So you see that this box will be bigger than what? This box. If you are going to pack dozen in this box, it will be bigger or heavier than what? Just the t-shirts. Okay. So you have to take note of that constraint. And that is what we have to pack into 1,200 boxes. Because that's what this car can carry. Okay. So given this, we can then construct, so this is better and better particulars about the problem. Okay. So these are, remember we've seen this before, the processing time, the cost or the budget, and then the profit. So we can use this to formulate what the objective function, not so. So it means that here, if you are, this is a problem where we have what? 4 decision variables. Okay? X1, X2, X3, X4. Unlike the preliminary problem where we just had what? Poles and then what? Mass. This one we have what? 4. Okay? So, and it is set up, so this is further information for us. So given, you can then label them. Okay, X1, X2, X3, based on the different t-shirts categories, which can then help you to come out with what? Your objective function. So the objective function is taken from what? The last column of what? The table. You see that. Profit per dozen. So you multiply the x's by their what? Profit per unit. Or per, in here, unit is a dozen. And then you get what? The objective function. So I'm just taking you through so that when I give you a problem, I will not be there to be explaining these things. Okay? So that will give you the objective function. So that one usually is easy to set it up. The issue is what? The constraint. The first constraint, which is the processing time, is easy because we are told that what? We have what? 72 hours to produce it. In other words, we cannot use more than 72 hours. So that's why all of them, these coefficients are from the table, remember. We'll come to the table. So X1, so X1 times this, X2 times this, X3 times this, X4 times this should be less than or equal to what? 72. So that's what we have there. Okay. Then we have what? The boxes, what? Constraints. The car has its carrying capacity or the capacity constraint, which is that we are told that the t-shirts, which are X3 and then X4, they are standard boxes. Okay? So they are standard, you don't have a problem. But the sweatshirts, they are 3 times heavier. So that's why you have what? 3 X1, 3 what? X2, the heavier one, because they are what? 3 times what? Heavier than these ones. So that explains why you have what? 3X1, 3X2, and then what? X3, and then what? X4. All of that should not exceed 1,200 boxes. Otherwise, the car cannot carry it. Yeah, overloading is not allowed. It's good wise. You see that if you are going twice, you see a cost. See, you are increasing cost. Okay. Now, then we have what? A budget constraint. Go to the table, you see cost. So the budget constraint will be what? X1 times 36, X2 times what? 48, X3 times 25, X4 times what? So that's how that one is done. And that's and we said that the maximum is what? 25,000. That's the maximum budget. That's the cost you can incur. Now, we are saying that in stock, if you look at the last part of the constraint, in stock, they said that they have what? 500 dozen of what? The sweatshirts. So X1, X2 is 500, and also 500 for the t-shirt. So X3 plus X4 is also what? 500. So that ends what? The constraint. Okay. Now, so once you set up the problem like this, as for the solution, it is easy. Okay? Because you can solve this either using the Excel solver or using what? The Excel QM for Windows. So if it is Excel QM for Windows, when you click on linear programming, how many constraints should you write? 1, 2, 3, 4, 5. So you have 5 constraints. So when you select 5 constraints, it is going to open a spreadsheet which will align the 5 constraints, and you have to enter what values. So when you come to this constraint, if you come to this constraint, all the decision variables have what? Constraints. If you come here, all of them, they have constraints. If you come here, for instance, there's no what? X3, there's no what? X4. So those columns, you put what? 0, 0 there. If you come to this one, there's no what? X1, there's no what? X2. So those columns, you put what? Those cells, you put what? 0, 0 there. Yes, please.
Please, in all the constraints, the resources requirement for the product is example at where the time processing time there is no time where that be given in the question, or you have to do for the time.
It's given. 72 hours is provided.
The processing time per at that side, because all the other ones were given in the question.
Everything is given.
This side. No, this side.
No, it's given.
So I'm asking that would it be part of the question?
It's part of it.
Oh, okay.
It's part of it. No, don't think too hard.
I thought the question is.
I'm saying you are thinking too hard. That's the problem. Your mind is telling you that it's difficult. Yeah, so you are thinking too hard. So yesterday I sent you exhibit 4.1. Open that. If you open it, that's what have been said on this book. You can open exhibit 4.1. Exhibit 4.1 is an Excel sheet. When you open it, this is the information that you have in it. But you are not going to have this pop out illustration. This is for teaching purposes. Yeah. But you will see that we have already entered the values there. So profit per bar. So these are the coefficients of the objective function. So they are rated x1, x2, x3, x4. They are written here. Then you have processing time, the constraints. Then you write the parameters there. Then the shipping capacity. Budget, you write the coefficients. Then you look at what? The blank what? Sweatshirts. And then the blank t-shirts, the constraints. You write them there. Okay. What you are seeing here is being solved. Okay? It's been solved. If you want to re-estimate, then you have to take out the values for the x1, x2, x3, x4 that are under production, but don't tamper with, because once you take them out, the profit will automatically become zero. Okay? Just how you did for the other one. Once you take them out, you take out this, that. You can then do the usual thing, go to data, then solver, and then you solve it. Once you solve it, you will have, this will be the optimal value. X1 will be 175, X2 57, X3 500, and then X4 will be 0. What's that? Are you there? Because I'm directing them.
We should clear it. Or we shouldn't clear it.
You can clear this. That's one. So you are 19. So when you resolve that, you see that this solution produces some answers that bring new insights. Because you see that now, if you look at the resources side, not all the slack values are zero. Remember, we said that the slack variable represents what? Unused resource. So it means that even if we arrive at an optimal solution, we'll still have what? Some excess resources for budgets, and then that's for blank t-shirts. Okay, so there are some slack values there, which basically mean level. So you should be familiar with interpreting results where the slacks are not zero. Okay, if I ask you to write out the slack values and interpret them, you should be able to write them out and interpret. So from my end, once you go through this, I'll be satisfied. I'll be happy with you. This another example. That one you have to follow the slides and do it. I've given you the sheets where you have up to, from this, it means that you have up to x10. So these are the equations. And this is the Excel sheet. So if you look at exhibit 4.5, that's what you follow to solve this one. And this has up to X4. They go through that one. That one is an investment example. So you can go through that. I think I've given you exhibit 4.7. You have exhibit 4.7. So you can follow that to do this one. I will not return to it again. So that is it. Any question?
When we get there.
All right, all the best.
When we get to the bridge, we go out. How long?